Okay, Algebra 1 students, in this video we are going to spend a few minutes going through some procedures. We've been talking about solving systems of linear equations by graphing from a conceptual standpoint and practicing how to do it. Now we're going to get procedural, okay? So here is your process. Step 1, graph your first line, okay? And how do you graph a line from y equals mx plus b? Well, you plot your y-intercept, which is b, okay? 0, 2. Remember, your y-intercept is where y equals 0 and x equals 0 and y equals something. I said that exactly backwards. So any point on this axis, the value of x is 0. And you can see if you looked at this equation, if I plugged in a 0 right there, for x. Then when I multiplied 0 times 2/3, well, it would equal 0 and disappear, which means all I would have left is y equals 2. So that's how that works. After you plot that point, you apply your slope. Your slope is m right there. In this case, it's 2/3. So you go up 2 steps, over 3 steps, and plot that point. Then you can draw your first line, okay? Step 2, graph your second line. Here's your second line, alrighty? So once again, plot your y-intercept, in this case, -1, and then apply your slope, down 1, over 1. Okay, you could plot that point, down 1, over 1, plot that point. And then you can, once again, draw your line. Because you can see that even though there's no number in front of the x, the number that's implied to be there is 1. So -1 over 1 is your slope. And I show you this here and here. Okay? The point where the two lines cross is your solution. And you see I've marked the solution in red. Let us remember, before we go to the next slide, that the solution must make both equations true. And in Algebra 1, here's a little Algebra 1 note. Look for the solution at a lattice point, okay? All of our solutions for our systems in Algebra 1 are all integers, okay? So, on this slide, we're going to go through the process for determining the number of solutions by observation. Okay? So remember, you've got 3 cases of systems of equations. You have systems of equations that have no solution. You have systems of equations that have infinite solutions. And then everything else has one solution. Okay, so when you're looking at pairs of equations in order to make a determination of how many solutions you're going to have, you're basically looking to rule out these 2 cases first. All right? So here we have the slopes are the same. All right, so look for your slope. This is how you would look for a slope in standard form. This would be your rise, and this would be your run. y over x, right? Because you would kick this term over. I go over this procedure at the end of this video. And then you would divide by the y coefficient. So this is your rise over run. And here's just your slope, okay? If the slopes are the same, then you know you have no solution. The lines are parallel. They are never going to cross. Our second case that you look to go through is the lines are exact multiples of each other. Not one term, young people, not two terms, but all three terms have to be multiples of each other. You can see in this equation, we have x plus y equals 4. The equation right below it, you can see we have 2x plus 2y equals 8. All three of these terms are the same as these terms up here multiplied by 2. Okay? That means that the lines are actually the same line. So it's infinitely many solutions. Any point that is on one of these lines is going to be on the other. Okay? Any other combination of lines is going to be one solution. All right? So once you go through and make sure that the slopes are not the same, and that the slopes are exact multiples of each other, then you're just going to know that I've got one solution. Okay. Here in this slide, we're going to determine, I'm going to walk you through how to determine if a point is a solution. Okay, so here's the question, is the point 3, 2 a solution to this system? Here's the system. Okay, so look what we do. We take the y coordinate and we substitute it right there for y. We take the x coordinate and we substitute it right there for x, and then we evaluate what we've got. Okay, in this case, it's -1 times +3 is -3 plus 2 equals -1. -1 does not equal 2. Therefore, this point, 3, 2, is not on this line. So therefore, if it's not on this line, then it can't be on both lines. So it's not a solution to the system. Now, if we had done this arithmetic and it did work out to where we got a true number statement, something equals something, then we would have had to have plugged that into the other equation just to make sure that it also was on that other line, because remember, the point has to make both equations true to be a solution. Okay? And last but not least, here is our last procedure for how to convert standard form of a linear equation to slope-intercept form. So why am I going through this right now? Well, if you are asked to graph a system from standard form, the easiest thing for you to do is to actually convert it into y equals mx plus b. Okay? So that's why we're going through this. So, step 1, you're going to kick the x term to the other side of the equal sign. by either, like in this case, subtracting 3x, so it cancels that 3x, or if this were a negative 3x, by adding 3x to both sides. So now you've got the x term on the other side of the equal sign from the y. Now you have to divide all three terms by the y coefficient. Let's recall our vocabulary from the beginning of the school year. A coefficient is a number, a constant that is multiplying a variable, like 4y. So we want to solve the equation for y, not 4y. So therefore we have to divide all three terms by 4. In the case of your slope, you're just going to leave the fraction alone, negative 3/4 x. Okay, that's what that's going to mean. But in the case of the y-intercept, I'm going to tell you right now that for our purposes, CUDA software has rigged all of these problems so that your y-intercept is going to be a whole number, an integer, a positive or negative whole number. In this case, 12 divided by 4 is 3. Okay? Then your final step is just to rewrite the whole equation in y equals mx plus b form. And there you have it. I hope that this video was helpful. I'll see you in the next one.